Hello, welcome. Today let's try to solve the last Leetcode problem, 110, balanced binary tree. So we are given a tree, we just need to check if the tree is balanced. So what is the definition of a height-balanced tree? So the binary tree is a balanced tree in which the depth of the two subtrees of every node never differs by more than 1. So for example, for the left side, this is 3 and 9. We think the depth is 2, so we will call this as depth 1. Or it is, we call it depth 2, but for the right side, it is depth 3, 1, 2, 3. Yeah, or you will calculate the depth as 1 from the left side, and from the right side, it is 2. And even for this node 20, from the left side, depth 1, and right side, depth 1. So there will be never a condition like the left side will minus the right side will be more than or equal to 2. Yeah, so it will be a balanced tree. But for this one, for the left side, the depth is 3, 1, 2, 3. For the right side, the depth is 1. So for the condition, it didn't meet the condition, so we're gonna return a false. Now let's try to solve the problem. Yeah, so for this problem, basically we're gonna check the depth of the tree. So I will define a function. I will call it depth. So inside I will give a root node, and here, yeah, because it is inside a class immediately, I'm gonna use a self. Now I'm going to check the depth of a binary tree. So how to check that? Yeah, if we solved the depth of a binary tree problem, it would be easy. Yeah, so we're gonna check the root. If not root, it means the root node does not exist. We're gonna return 0. Otherwise, we're gonna return the maximum of self dot depth, root dot left, and self dot depth with root dot right, and the maximum of them will plus a 1. So this will be the depth of a tree. So while we are checking the balanced tree, we're gonna use this depth condition to check. Yeah. Now we are trying to write the is balanced function. Yeah. So for the is balanced for the first condition if not root. So this means the root node does not exist for this condition. So we're gonna return a true. All the conditions is for everything we checked is okay, we come to the root node. Yeah, this root node does not exist. And for this 7 also, root node does not exist. We're gonna return a true. And then we're gonna find the false conditions. So for the false condition is if the left side minus the right side. Yeah, if the depth is more than or equal than 2, we're gonna return a false. So how can we check that? We can use an absolute. Yeah, because this can check left minus right or right minus left. Yeah, so it would be root dot. Yeah, we're gonna call the depth function the self dot depth root dot left minus self dot depth and root dot right. Yeah, so if the absolute difference is more than 1, so we're gonna return a false. Yeah, if the left tree minus the right, if the depth of the left tree, like this example, minus the depth of the right tree is more than 1, so we're gonna return false. Otherwise, we're gonna call the recursive function to check for the next level. Yeah. Otherwise, we're gonna call this is balance. So self dot is balance, root dot left, and self dot is balance, root dot right. Yeah. So this basically means if we find the root node, if there is a root, if the root node does not exist, we're gonna return a true immediately. Otherwise, we're gonna check the depth from the left side and the right side. Yeah, if it is more than 1, we're gonna return a false immediately. For this root level, we're gonna check the left and right. Yeah, If it is still true, we're gonna go to the left side to check this node 9. For example, if this is true, but from here, this is already a false. Yeah. So if for this example, if this is true, we're gonna check this 9 and with this 20. So the depth from the left side, we're gonna check this 9 node. So this tree is also true from the left side. This is a self is balanced root dot left. So this means from 9 it is a true. And from 20, we're gonna check it's also a true. So finally, it will be true. Now let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. Yeah, basically this is the definition of the balanced tree, and the easiest way to solve it is by using recursive function. And yeah, we already solved the depth of the tree Leetcode problem. Now we can use it immediately to solve